the GRIHA Way. I'm Sita Mahalakshmi, Deputy Manager with GRIHA Council, your speaker for the session. I now request Ms. Shabnam Basi, Secretary, GRIHA Council, to give the opening remarks. Over to you, Shabnam.
A very good evening to all of you. I welcome you all to today's webinar that has been specially designed for the students, aiming to sensitize you about the green buildings and the way GRIHA can be used for your academic projects and onwards professional life. We would showcase some of the GRIHA case studies emphasizing on the strategies that were adopted to reduce the impact on the natural environment. By the end of today's webinar, we would have understood the GRIHA rating systems along with the case studies, and would have also covered the daylight calculations, effective SHGC calculations, along with the energy performance index and water calculations. So now I would like to hand over today's session to Sita, who is the main speaker for today. Considering that we have a large number that is attending today's webinar, I would encourage you all to kindly ask us questions on the chat. We would try and address most of the questions that will be asked today. Nevertheless, if there are questions that have not been answered today, we would try and answer them latest by tomorrow. So you will get all these questions answered tomorrow, and we would be uploading them on the website, the GRIHA website. So with this, thank you very much for joining once again. And I hand over now to Sita, who is the main speaker for today. Over to you, Sita.
Thank you very much, Shabnam. Once again, good afternoon to one and all. Before we dive deep into the webinar, let's just quickly get acquainted with the instructions for smooth operation of that webinar. Your microphones have been put on mute mode and cameras have been disabled. In case you have any queries, as Shabnam mentioned, any queries or comments can kindly write that in the chat box. All the queries and the replies shall be uploaded on the GRIHA website after the webinar, if you're unable to address the questions in this session. We shall now proceed with the session. Let me take you through the flow of the webinar. Sorry to interrupt. Vechi, the slide transition is not happening. Can you please check it once?
Please stop sharing and sharing again. Check that.
Okay. So let me take you through the flow of the webinar, Green Buildings, the GRIHA Way. To give you all an insight about GRIHA, let's understand the basics of what a green building is, its attributes and benefits, followed by insights on GRIHA Way of green building through variants of GRIHA ratings along with case studies of GRIHA rated projects. I will also give you a few tips and tricks on or say thumb rules for calculating daylight area, and also help you learn how to calculate EPI of a project as per GRIHA. So let's understand what is a green building. I request Mr. V to roll out the poll, please. Mr. Virji, can you please roll out the poll for the question number 1? Yes, I request you all to answer the poll on your screen. We'll hold this for about 5 to 10 seconds. Please do answer this poll. I hope all the participants have answered the poll. Yeah, here are our answers, right. I guess everybody is on the right track. So a green building is which uses less water and optimizes energy. Okay, so I thought people will opt for any either A or B or C, but most of them have opted for the right choice, which is all of the above. But however, people nowadays believe that a green building costs more than a conventional building. But as a fact that the design of a green building through informed decisions makes it cheaper than the conventional building because it gives as a payback. So I'm sure you agree, you all agree with this. So a green building is nothing but a space envisioned with a holistic understanding of built environment and its effects, either positive or negative, on the environment and habitats. It also puts in efforts in amplifying the positive and mitigating the negative effects throughout the entire life cycle of the building. Green building is the one that uses less water, optimizes energy efficiency, conserves natural resources, generates less waste, and provides a healthier space for its occupants. Now that we have understood the concepts of green building, but why do we need a green building in the first place? Why not a regular building? This is how green building optimizes all. So why do we need a green building? Why not a regular building? Or say conventional building? Let's understand what are the features of or impacts of conventional building. A conventional building uses large amounts of resources such as energy, land, water, and raw materials for their construction and operation. It is responsible for large greenhouse gas emissions and other harmful air pollutants. It also generates larger amounts of construction demolition waste, posing serious impacts on plants and wildlife. So let's learn a little more about green buildings to help ourselves. So what are the key attributes of a green building? Consideration of sustainability aspects in all phases of building design and planning, use of environmentally friendly building materials and products, use of efficient systems, use of construction techniques and systems which makes the building easy to operate and maintain. But what are we getting through this? What are the benefits of it? We save energy, we save water, we save on utility bills for a tenant or a household, lower construction costs and higher property values for building developers, increased occupancy rates, job creations, provides thermal comfort with spaces of better indoor air environment quality. I must say that a research suggests that better indoor air quality with lower concentrations of carbon dioxide and pollutants and high ventilation rates can lead to improvements in the performance of up to 8%. Health and productivity of the workers in green, well-ventilated offices record a 101% increase in cognitive scores. But how do we design them? As we all know, for initiating the process of design, climate analysis plays a crucial role in envisioning the design of the space. Let's familiarize ourselves with the types of climate zones. So as per Köppen climate classification, the world has been classified majorly into 5 major climate groups and into 53 various climatic zones in the world. And let's check how many India has as per Köppen classification. Yes, India is composed of 11 different types of climates. But do we have any climatic classification for India of its own? Yes. NBC has classified India into 5 climatic zones, namely hot and dry, warm and humid, composite, temperate, and cold. The building industry develops depending on 3 major factors, and they are climate, land availability, and population for whom the structure is being built. And for standards and codes, the whole world will always look towards West, especially USA, because It has got the best standards in terms of being a developed country. Before adapting these standards for the design, let's look at the reality of three major factors: land availability, population, and climate of India and USA. So the green bar indicates India and the white bar indicates USA. Let's look at the first bar diagram. It talks about land area availability, and the second talks about the population in each country. If we compare, USA has got land 4 folds more than India. But if we observe the size of the population, India beats USA by 5 times more. Here, we have to understand that land is finite resource and population keeps increasing. Let's look at another parameter. Let's dig a little deep into it. So if you look at various metro cities, let's start comparing metro cities in India and USA. Its population, land, and population densities. We could clearly see huge disparity in terms of relativity between population size and land area available and the densities. For example, let's look at Chennai. So if we look at Chennai, the metro population of Chennai and Dallas is almost similar, but yet Chennai takes a higher upper hand. But if you look at the land availability between Chennai and Dallas, Dallas is like 5 folds more than whatever land is available with Chennai. And in the same case, as we already understood, if the population is more and the land availability is less, density of the population shoots up. And if we could see that it is 5 times more of Dallas. We have to understand that, or let's also look about climatic conditions. We have looked about land and population. Let's also check the third factor, climate. So let's check about Chennai. So in the Chennai, if we look at the climate, the highest temperature which is recorded is 45 degrees. And if we look at Dallas, Chicago, the highest recorded is of 10 degrees, 19 degrees. There is no comparison between the temperatures also as such. We have to understand that informed decisions plays major role rather than, I would say, drive the design of that space. So if we try to copy paste from international standards, that's not going to work. So let's see, here there are 4 buildings. Can we identify in which climate is it built? Any one of it? We cannot. And I'll give you the facts. The first 2 pictures in the first row are the pictures of buildings from India, one from Gurgaon and one from Hyderabad. And the second 2 pictures in the row 2 are the buildings from USA. In spite of disparity in terms of land, population, and climate, we end up with buildings which looks the same as buildings in the West. To get to that, let's have a sneak peek to the buildings which we already have. There are 4 pictures on the screen depicting different build forms, named A, B, C, and D. I request Mr. Veer to roll out the poll question number 2. Mr. Veer, can you roll out the question number 2, please? I request all the participants to answer the poll question. The screen remains for 5 to 10 seconds. Please provide your answer. The question is, can we identify or guess the location through the buildings? What is the location or region of the house in the picture B? Yes, most of you have answered right. Yes, Kerala, warm and humid. Yes, absolutely right. Yes, it is because every component of the structure has been designed and constructed based on the climate of that particular place. It rains most of the year, and so pitch roofs for the ease of draining the rainwater, extended eaves to protect the structure from rain, and so on and so forth. So it is important that we have to move forward with an informed decision rather than just trying to copy from West. Inception of GRIHA. I'm sure everybody knows about which building is this. Yes, this is the office of CII, Confederation of Indian Industry, located in Hyderabad, Telangana. This is India's first green rated building. Most of the people are not aware that TERI, the Energy and Resource Institute, was the consultant for this project. Later in the year 2001, this project has been awarded LEED Platinum rating. During the course of the work on the project, TERI has realized that Indian construction industry needs a rating system which is rather tailored for Indian climate. From then, TERI started working on green rating and released TERI GRIHA in the year 2005. GRIHA. GRIHA stands for Green Rating for Integrated Habitat Assessment. GRIHA is a tool developed to measure the greenness of a building throughout its life cycle. And when we talk about life cycle, this tool helps in designing, construction, and operation of a green building. As a matter of fact, we'll be able to manage or control anything, may it be human resource, may it be food we eat, or time. It can be managed only if we keep a track of it or count it or measure it. Yes or no? Yes, only if we keep a track of it. Adapting the same, if you look at the GRIHA criteria, benchmarks are provided to measure the performance of the building. That's how the principle behind GRIHA rating is what gets measured, gets managed. Later in the year 2007, GRIHA has been recognized as National Rating System of India by MNRE, Ministry of New and Renewable Energy. In the year 2009, GRIHA Council has been established as a separate entity. GRIHA has been recognized as a tool for implementing RE in the building sector by the Climate Reality Project, an international organization funded by Mr. Al Gore in 2008. It has been recognized as an innovative tool for sustainable development by United Nations in the year 2009. And in the year 2010, UNEP, United Nations Environment Program, SBCI, Sustainable Buildings and Construction Initiative, has developed the carbon-carbon metric for international building energy data collection based on GRIHA inputs. GRIHA rating has been recognized as India's own green building rating system and part of mitigation strategy for combating climate change in India's INDC submitted to UNFCCC. I'll give you a quick peek of benefits of GRIHA rating. What are the benefits that a project gets going for a GRIHA rating? A reduction in the energy consumption by 30 to 50%, integrating of renewable energy to offset the grid demand, reducing building water consumption by 40 to 50%. It ensures health and safety of construction workers on site, ensures compliance during operation with the help of post-occupancy performance audits, ensures waste management during construction and operation, helps in reducing lighting energy by 5 to 30% or its equivalent is met through renewable energy production, and reduction in the operational cost by 30 to 40% with negligible impact on the project cost. GRIHA has more than 2,000 projects registered right now, and then with almost 850 million square feet of built up area, which is registered under GRIHA rating. Municipalities like Pune, Pimpri Chinchwada, Noida, Greater Noida, states such as Delhi, Punjab, Goa, Sikkim, and organizations as CPWD, NDCC have adopted GRIHA rating for their infrastructure. GRIHA has a vast catalog of variants, and buildings like homes, offices, schools, hospitals, apartments, larger campuses, restaurants, museums, infrastructural facilities like airports can be rated under GRIHA rating. With a vast catalog of variants, GRIHA looks at the building from two standpoints: new buildings and existing buildings. Under new category, GRIHA offers 4 different ratings, and under existing building category, GRIHA offers 2 different ratings. The first category under new buildings is SWGRIHA, which is simple, versatile, affordable GRIHA, which is applicable to a project which have built up area less than 2,500 square meters. And the next rating is GRIHA. It is applicable to the project which has a built up area of more than 2,500 square meters. GRIHA for larger developments, which is for large scale projects such as SEZs, campuses registered under GRIHA large development with site areas more than 50 hectares. GRIHA for affordable housing is yet another rating for projects under PMAY scheme, Pradhan Mantri Awas Yojana scheme, where the built-up area is around 2,500 square meters. There is another rating as well, which is GRIHA cities for the upcoming cities in the country under Smart Cities program. Under existing buildings, yet another 2 ratings, which is GRIHA EB, which is for commercial projects greater than 2,500 meter square of built up area, and also GRIHA for existing day schools, which is for the schools. Now, today in this webinar, I'll give you an overview of GRIHA version 2015, which is the 3rd edition or the version of GRIHA ratings. What are the key features of GRIHA rating? It's a performance-based rating. It's a performance-based rating wherein if better the performance of the project, for example, higher the savings in the energy from the benchmark of GRIHA, lesser the generation, reuse or recycle or disposal of waste, etc., attracts higher rating for the project. It's a common sense oriented rating system with non-applicability clause, which is based on the individual project, its scale and its requirement. Every project is unique and every project not necessarily be meeting certain facilities or provisions. In case, the project can opt for non-applicability. GRIHA lays emphasis on cost-effective strategies for making green buildings, believing that installation of high-end technologies doesn't necessarily guarantee the building to be green. It also emphasizes on integrated design approach towards envisioning green buildings. GRIHA rating is meant for not only AC buildings, but also non-AC as well as hybrid buildings, which can be rated under GRIHA. When should a project team, or at what stage of the project team should approach GRIHA for the building to be rated under GRIHA rating? For most of the construction projects, which may vary based on their size, the number of stakeholders involved, the budget, delivery date, etc., and the project's life cycle, from the simplest to the most complex, it is categorized into 4 different stages. Preliminary stage of the project is design. That includes programming and feasibility, schematic drawings, design developments, contract documents is what is called at a design stage. In the later stage, of construction of the design. In various aspects like quality control of the project, how and where to store all the materials, the hours that everyone will be working, the schedule of the project, when the project is completed, all these comes under construction. Then, operation. The owner or tenant occupies the building and starts using all the different systems, equipments, and materials that have been installed or used in the project, which is operation. Any system without proper care will not work to its full efficiency. So, maintenance also plays an important role rather than just billing. The maintenance stage encompasses issues like the project, the equipments which we used, the systems which we installed, their control procedures, the regular maintenance and schedules for the same. If any specific team is required to carry on with the same, all these aspects come under the maintenance stage of that project. All these play a major role in maintaining the building or the systems in the building. But where do GRIHA come into the picture, or at what stage? GRIHA encompasses all the stages of the project, right from the beginning, design stage, till the maintenance stage. The project should approach GRIHA during the design stage itself. So let's look at GRIHA ratings. GRIHA rating has been classified into 9 sections, such that all the stages and processes of the project which were discussed earlier has been categorized and encompassed into these 9 sections. It has been further divided into criteria. The 9 sections, 31 criteria. The 9 sections are site planning, construction management, energy, occupant comfort and well-being, water, sustainable building materials, solid waste management, socio-economic strategies, performance monitoring, and validation. These 9 sections are further divided into 31 criteria. The sections and the overview of all these sections will be covered in this webinar. These sections are weighed at various weightages. If we look at site planning accounts for about 8%, construction management 20%, occupant comfort and well-being 12%, water 17%, sustainable materials 14%, construction management 9%, solid waste management 6%, socio-economic strategies 6%, and performance monitoring and validation 8%. If we look at it, the energy constitutes of higher percentage of 20%. Next comes the water, which is of 17%, and then sustainable building materials, which encompasses of 14% of the total rating. How does this rating system work? It's a percentile-based rating system. The proposed rating scale for the project is, if the project acquires a percentile of 25 to 40, acquires 1 star. A further spike of 15 points will make the project eligible for an upgrade in the rating that it receives by 1 star. Let's go into the details of the rating process as such. GRIHA strictly follows a paperless rating system where all the registrations, submissions of documents are done through online. For any project to be rated under GRIHA, the project team has to first register with GRIHA at www.grihaindia.org. A project is considered registered only after the confirmation of payment and the project being issued with login credentials for further process. Post-registration, GRIHA Council officials will conduct an orientation workshop with the project team. This team necessarily should include the architect, owner, builder, HVAC consultant, MEP consultant, and any other consultants associated with the project. The workshop is aimed at explaining the project team of the rating process, necessary documents to be acquired or collated for submission for compliance with GRIHA rating. After the workshop, we conduct, or GRIHA conducts, first and second due diligence site visits. The first site visit is conducted when the project reaches the plinth stage, and the second is conducted when the GRIHA Council by the GRIHA Council officials once the shell work is complete and the process of installing necessary equipment like glass, flooring, HVAC ducting, etc. is going on in the project. Once the construction is complete or on the verge of the completion, the project team is supposed to submit the entire documentation back to us online, stating that we are ready or the project is about to be completed, inviting us to proceed further in the process of rating. The GRIHA Council team executes a preliminary evaluation. After the preliminary evaluation is done, simultaneously, a final site visit is scheduled and done. In this final site visit that we conduct, we make sure that all that is claimed in the documentation submitted for preliminary review are in place in the site or not. The project team is required to submit the final documentation as per the comments and feedback provided in the preliminary review and also in the final site visit report submitted by GRIHA Council officials. After this final evaluation is done, based on the documentation submitted and observations during the final site visit, GRIHA provisional rating is awarded to the project. It is only after the submission of post-occupancy audit report of the project with at least 75% occupancy for a year. The audit report will be reviewed and the final GRIHA rating is awarded to the project. Now I'll explain the GRIHA version 2015 section wise as explained to you earlier before. As I've mentioned, GRIHA version 2015 is classified into 9 sections and further broken down to 31 criteria. Each criteria is structured with an objective, which is what is to be achieved. That is intent. With a requirement, as in what commitment is to be done by the project. With an implementation, what compliance should be done for that particular criteria to meet the requirements. And validation, as in how will it be checked. And in all these criteria, let me tell you that there are 4 different types of variations, which is mandatory, partly mandatory, non-applicability, and which earns the project the points. Mandatory is a project should definitely meet that criteria, otherwise GRIHA rating is denied. Partly mandatory is if a criteria has subsections in it which are mandatory, then it is considered partly mandatory. Non-applicability clause is when a project provides sufficient documentation saying that the project doesn't need to go for the particular criteria, then that is considered as non-applicable. And more savings can earn more number of points. The first section is site planning. This is further broken down to 4 different criteria, mainly site selection, low impact design, designed to mitigate urban heat island effect, and also site imperviousness factor. Site selection, this section makes sure that the site meets relevant master plans, local development plans, which is mandatory, to promote design strategies which enables the project to factor in ways in which the natural site features can be protected or incorporated into the project design, to ensure incorporation of site design strategies which assist in reduction of urban heat island effect, to also ensure implementation of site design measures which assist in reduction of overall site imperviousness factor, reducing urban rainwater recharge, which plays a major role for urban flooding if not addressed. Urban heat island. What exactly is urban heat island? The phenomena of where a city center gets warmer than the surrounding areas is what is urban heat island. How can we reduce it? We can provide soft pavings, covered with high SRI coatings, shaded by trees, shaded by vegetated pergolas, shared by solar panels. And if the project is of a brownfield or a redevelopment project, or there are at least 5 basic services within the walking distance of 500 meters from the entrance gate of the project, then that project will get or earn more points in this section. Let's look at a case study. This is Akshay Urja Bhavan of Panchkula in Haryana. This building is technically oriented, placed on north and south axis in order to receive sun from the southern side. Most windows are placed on north facade of the building to keep the building naturally daylit. East and west windows are oriented towards south to have easier sun control through the shading devices. South has a wide spread of landscaped area. East and west windows are oriented south. These windows help the office spaces on those faces to receive daylight. Central courtyard and single loaded corridors help provide visual comfort by natural light. Solar chimneys to the south were built to aid ventilation through stack effect to some of the non-AC spaces in the building. And misting is also done in the courtyard to cool the ambient air, which is circulated into the building through the stack effect of solar chimneys. AAC block masonry cavity walls along with XPS foam insulation is done in east and west facades of the building, and fly ash brick masonry done in north and south facades of the building. Let's move on to the next section, which is construction management. This section is further broken down to 3 criteria. As the name explains, this section looks at the ways to manage or take necessary and relevant measures during construction. So the intent of this section is to minimize air and water pollution during construction on site, adapting a three strategies in which providing 3-meter high barricade through the periphery of the site is mandatory. It further ensures to preserve mature trees and fertile topsoil on site, minimizing the impact of construction activities on existing landscape. This project can opt for non-applicability if there are no mature trees on site, if the topsoil is not fertile and which cannot be made fertile through organic means. It is mandatory to ensure that no existing mature trees are cut on site, or transplant mature trees within the site and ensure that they survive, or plant 3 trees for every 1 tree cut of the same species, or a combination of all the above. Providing wheel washing facility at the vehicular entrance of the site, covering the fine aggregate of building materials and excavated earth on the site with plastic or geotextile sheets, implementing spill prevention plan, planting more number of native trees, preserving topsoil during construction, and ensuring adoption of good construction management practices on site can earn more points to the project. Let's move on to the next section, which is energy, which takes up about 20% of the total rating. This section is further broken down to 3 criteria, which is energy efficiency, renewable energy utilization, and low ODP materials. We have to understand the basic concept of reduced energy is because if the occupants in the habitats are using less energy, which means they are facilitated with measure that ensures less energy consumption in the project, then also adding up to supplying the energy through renewable energy sources. So the intent of this section is to ensure the efficiency of the project, making sure the project meets the mandatory requirement of ECBC and all fans must meet BE 5-star rating. This is mandatory. The project EPI should be below GRIHA benchmark. What is this EPI? EPI is nothing but Energy Performance Index of the building, which helps in understanding what is the performance of the building in terms of energy. It is also to ensure incorporation of renewable energy sources in the project, where offsite a part of annual consumption of internal, artificial lighting, and HVAC energy demand. Note this, we only calculate or we only look at internal artificial lighting and HVAC load for calculating EPI. This is mandatory. To ensure the use of materials in building insulation, such as HVAC and building insulation, and providing refrigerant in HVAC and firefighting systems, which is of low ODP materials. It is also mandatory. And if the peak heat gain through the building envelope meets the GRIHA benchmark or GRIHA peak heat gain factor threshold, which is only meant for AC buildings which are non-residential, then also the project is considered energy efficient. So if 100% of outdoor lighting fixtures meet the efficacy requirements of GRIHA, or if the renewable energy systems produce more than the GRIHA benchmark, then the project can opt for additional points in this section. If a project can achieve energy demand reduction and can also produce through renewable energy results in reduced energy consumption. So how can we produce renewable energy? There are different ways of producing renewable energy through fuel cells, geothermal, small hydro plants, through biomass, wind energy, and solar power as well. Nowadays, solar panels that can act as a roof or a facade or building integrated photovoltaic panels are also seen in the market for use. As we are discussing about EPI of the project, that it should be below GRIHA benchmark, let's do an exercise to know how to calculate EPI. As I've already mentioned, EPI is nothing but Energy Performance Index. So there is a benchmark based on climate classification, the type of the building, and also the occupancy of the building. If you look at the table, it has been classified into these different variations. So to tell you again that for EPA calculations, we only use internal lighting load and HVAC load together. So I'll explain how to, for example, let's say this is the project, which is an office building located in New Delhi. So the minute a project is mentioned that it is an office building, it comes under this first category, which is commercial, institutional, academic, hospital buildings. And it is located in New Delhi, which comes under composite climate. So we can consider, and the occupancy schedule which is mentioned is daytime office building, which is of 5 days, 8 hours per day, which means the benchmark of GRIHA prescribed for this office building, which is in New Delhi and of daytime office, is 90. So if you have to calculate the EPA of a building, let's do an exercise of that. We have to calculate the EPA of the building to understand the savings in the energy performance as per GRIHA version 2015. I'll explain how to calculate this. Okay. So we have to understand what is the total load or what is the total consumption, which is, as I mentioned, interior lighting load plus HVAC. That accounts for about 7,40,000 kilowatt hour per year. And the formula to calculate EPI is total interior lighting plus HVAC load by total built up area, which is 7,40,000 kilowatt hour per year by the built up area, which is given is 11,000 square meters. So the EPA comes to 67.27 kilowatt hour per square meter per annum. But as per GRIHA benchmark, it is 90. So what should be the savings? The percentage savings is 25%. Hence, it comes with 3 points. The project can claim for 3 points under 25% savings in that energy consumption. I hope everybody understood how to calculate EPA of that project. So let's move on to the next section. Occupancy, comfort, and well-being. So this section is further broken down into 3 different criteria, which is achieving indoor comfort requirements, maintaining good indoor air quality, and use of low VOC paints and other compounds in the building interiors. The intent of this section is to ensure that the building space are designed to deliver visual, thermal, and acoustical comfort to building occupants, and to design and monitor our ventilation systems such that indoor air quality meets the minimum requirements as per the standards. And the standards are National Ambient Air Quality, ASHRAE standard 62.1, section 4 to 7, and the ventilation for acceptable indoor air quality of CPCB norms, and to promote the use of low VOC and lead-free interior paints as well as low VOC adhesives and sealants in order to maintain good indoor air quality for that project occupant. So let's look at few examples. Is providing visual, acoustical and thermal comforts are necessary? Yes, I'll show you an example. Unfortunately, this is our office building in Delhi, wherein though there is a window where it allows good amount of light, but no person would be able to sit in that place and continue with the work. It is because the light is more, which is causing glare, which means providing a window for light doesn't make sense, but we have to make sure that the light which is entering into the space is comfortable for that particular activity. Let's look at another example also. It's an office space with a good stretch of windows, but what we have observed was the windows are letting too much of glare and these people always used to put up blinds and cover it. Then what is the point in providing the windows? So we need to calculate the amount of light which is needed and then design the spaces accordingly. So how do we determine how much of floor area is receiving daylight? How do we calculate that? So I'll give you a thumb rule, which is also mentioned in ECBC to calculate the floor area receiving daylight from a particular window. So consider this is the plan of a room where the width of the window is W and the height of the window, let's say the height considered is from the finished floor level till the lintel level is H. So to understand how much of light is being or how much of floor area is receiving daylight, this is the simpler calculation, which is 1 meter on either sides of the window. Considering W as the width, you take 1 meter on either sides of that width, and if the height of the lintel from the finished floor level is H, the light enters inside the building and the depth is calculated as 2H. So if you want to calculate the daylight area which is being received into the room through this particular window, then 1 meter plus W, which is width of the window, plus 1 meter on the right hand side of the window into 2H times 2 times the height of the lintel from the finished floor level. I hope you understood this. Okay, this is a simpler calculation. This is how we can calculate, or we can come up with a number or size of the window, whether we need so many windows or not, or what should be the size. This also helps in understanding what should be the depth of the room, which can cater or which can be well lit through the daylight. So let's do a small problem here. Okay. Consider the window size is 1.2 meters by 1.5 meters and the lintel height is 2.1 meters. What is the floor area that receives daylight? So I request everybody to solve this problem. We'll wait for 2 to 3 minutes for you to calculate. So W is given as 1.2 meters and H needs to be considered as 2.1 meters. I repeat, H shouldn't be the height of the window, but it should be the height from the finished floor level to the lintel height, which is 2.1. So I request every participant to do this small calculation. We'll wait for 2 minutes to know your answers. I hope the calculation has been done. Now I request admin to roll out question poll number 4. I request you to roll out the poll 4. Yes. Now, all the participants, I know you have done the calculation. Please do answer it. Let's check how many have got the right answer. Yes. Can we get the answers, please? Wow. Most of you have got the right answer, which means yes, you've understood. So the calculation goes on this way. Sorry, admin, can you please check? I'm unable to transit through the slides.
Click on the slide and then try.
Okay. Yes, thank you. So the daylight area is 1 meter plus the width of the window, which is 1.2, and 1 meter on the right side as well, into 2 times the height, which is 2.1, 13.44. Absolutely right. Good. Good that we have learned 2 types of calculations today. Good. Moving on to the next section, or I'll give you another insight into the same daylight calculation. So let's consider this case. Okay. So try calculating the area of this open plan sitting. So the general mistake what everybody does is they'll take W as 1.5 because W2 is given as 1.5 and H as 2.1. Perfect. But daylight area 1 meter in plus W plus 1 meter into 2H. So what are the number of windows here? W2, 2 into n times of W into 2H. There are 14 W2s in this open plan setting. So 2 plus 14 into the width of the window. And that's how people will come up with the answer. Do you think this is right? This is where the catch is. It is an incorrect method of calculation. You have to avoid repetitions of the area, which is, I'll explain it to you here. Look at this. Considering the 1 meter on either sides of W2 and then 2H depth, if you map it out on the floor plan, there are repetitions between each windows, which means one window is catering to the same space or 2 windows are catering to the same space twice. So if we have to calculate, why do we calculate the repetitions? We calculate the floor area. So we consider it only once. So we have to avoid repetitions. So formulas in terms of N into or Excel sheet calculations with putting just the window doesn't work in this case. You have to map it out, the plan, and then work it out. And sometimes what happens is, let me take you back to this. So as we calculating the depth as 2H, okay. For example, the height is 2.1 meters, but the room size is only 2 meters. But people will automatically consider in place of H, they'll consider 2.1 and then take the area. For suppose, in this case itself, consider that the room size is lesser, let's say 2 meters. And the room area will be lesser than the daylight area. So you have to make sure you plan it or map it properly on the floor plate. Then only you'll understand all these intricacies. You cannot just work it out with Excel sheet, or you cannot just use N into and then do the work. And sometimes people consider the window height as H. It is not window, it is from the finished floor level till the lintel level. So moving on to the next section, which is water. Yet again, this section is being divided into 5 different criteria, which are low fixtures and systems, reducing landscape water, water quality, on-site water reuse, rainwater recharge. The intent of this section is to reduce the water requirement and maintain quality through ensuring the use of low flow fixtures, and also to promote planting of native neutralized flora and use of water efficient irrigation systems for landscaping water. It also helps in ensuring the quality of water being used in the project meets the relevant national standards, promoting recycle and reuse of wastewater as well as reuse of captured rainwater on site to meet the water demand, thereby reducing the water requirement from the local municipality. It also encourages the supply of water to the groundwater aquifers, encouraging recharge of groundwater aquifers as well. Reducing the water demand through this selection of low fixtures by 30% below the GRIHA benchmark is mandatory. And the water used for various purposes like drinking, irrigation should conform to BIS standards. If all the faucets which are installed or all the fixtures which are installed in the space with water head height less than 5 meters, then this project is exempted from this calculation. And also, if the total wastewater generation on the site is less than 10 KLT, or if CGWB norms suggest that the groundwater table is too high and the groundwater recharge is not needed, the project can be exempted from this section of and the criteria in this section. And if STP is installed on site, meeting the CBCB norms, additional savings of water reuse and recharge of surplus water can earn more points. So this section talks about understanding the demand, understanding the supply, and then how we can mitigate and work towards reduction of water demand and also encourage supply of water through reuse and through recharge of rainwater. This is how it is. We have to reduce the water demand. So next section is sustainable building materials. This section is again further divided into 3 different criteria, which are utilization of BIS recommended waste materials in the building structure, reduction of embodied energy of the building structure, and use of low environmental impact materials in the building interiors. So this criteria basically helps to promote the use of BIS recommended waste such as fly ash or burnt slag or any other BIS recommended waste having properties similar to conventional constructions for building construction. So this also looks at reducing the embodied energy of the building structure through the use of low embodied energy materials. If the project demonstrates a reduction of combined embodied energy of load bearing and of structure and masonry walls by at least 10% below the GRIHA base case, then it gets 1 point. And furthermore, the project gets more number of points. It also helps in promoting installation of low environmental impact materials in the building interiors, which is if the project demonstrates 25% of all the materials used in the building interiors meets the GRIHA criterion low impact material requirements, then it will get 1 point, and furthermore will earn more number of points to the project. Moving on to the next section is, so yeah, in sustainable building materials, there are 2 different materials which are visible building materials and invisible building materials. Structural and non-structural materials, which goes into external claddings, internal finishes, structural and non-structural. GRIHA don't look for external cladding and finishes. So if you provide low embodied energy material in terms of external claddings and finishes, they are not accounted for. Moving on to the next section, which is solid waste management. Solid waste management section is divided into two different criteria, which is avoid post-construction landfill and treat organic waste on site. So the intent of the section is to provide infrastructure to future occupants of the projects so that they can sustainably manage on site the solid waste during operation phase, and to promote recycling, reuse of organic waste on site. In this, the project can claim for a non-applicability if the total waste generated on site is less than 100 kgs per day. Then the project can go for non-applicability clause. So, if we look at solid waste management, first, if we could segregate the waste at the generation stage itself and store it at different levels, maybe building level, maybe site level or city level, and promoting disposal or recovery of resource or reuse of it or making it a compost, then the project will earn points through in this section, solid waste management. Next, the section is socio-economic strategies. This section is further divided into 4 different criteria: labor safety and sanitation, design for universal accessibility, dedicated facilities for service staff, increase in environmental awareness. So the intent of this section is to ensure safe, health and hygienic working and living conditions for the construction workers working in the project, along with providing or promoting adoptions of measures to promote universal accessibility or to make the project universally accessible to differently abled person, and to promote the provision of resting space and toilets dedicated for project service staff, and also to create awareness on sustainability amongst the building users and visitors. Let's look at few examples of this. So in this slide, you can see that all the personnel are provided with hats, gloves, jackets, and also the shoe. So this is how you have to enable the laborers or construction workers on team with all the safety measurements. And if you look at this picture, this person is provided with a harness because as he is working at heights, and it is must and should to provide a safety harness for people or the construction workers working at site. So in this section, labor safety in the construction site takes prominence. Let's look at sanitation. If the project is providing accommodation facilities for the labor, these also will be checked. The accommodation provided for the construction workers should be well ventilated and daylit. And also they have to make sure that the toilets which were provided are clean. So let's look at examples which are across, which we usually see in Indian scenario. This is how we look at. This is how the scenario is. All the construction workers will work real hard to come up with beautiful buildings, but we do stay in them. And most of the projects don't care about how these construction workers are staying, how is the facility, or how are the amenities which were provided to them. Because GRIHA understands that safety of labor and proper amenities, healthy amenities for the workers also plays a major role in the timeline of the project as well. So this kind of scenarios needs to be avoided. And in terms of universal accessibility, I'm sure that you all know that NBC gives a standard of how a washroom size should be and what are the necessities which needs to be provided, right from providing ramps with handrails at 2 different levels for people who are disabled and people who regularly use, providing sliding doors for the toilets with the horizontal grab bar and providing grab bars inside the toilet for differently abled, providing a specific facility for differently able people to park their cars and also lifts with braille and audio assistance for them. So all these come under promoting universal accessibility in your project. So all these needs to be provided in the project. Coming to environmental awareness. If a project is creating awareness on sustainability amongst the building users and also visitors through any means, either by rallies or either by putting up posters or either by educating visitors or even conducting site visits for the students or visitors to know about the green features in the building, also come under increasing awareness. Then the project can earn points in this criteria as well. Then comes the section performance monitoring and validation. Yes, we have done all these things. We have included all the measures, we have adopted various strategies, but then how do we make sure that it is a green building? As I've said, GRIHA believes in what gets measured gets managed. So if we add a performance monitoring system to all the available meters or all the facilities we have provided, we can make sure that, or we can have a control over what is the demand, what is the supply, and what are the measures we can take to mitigate this higher usage and reduce and look for the optimization. So this section is furthermore divided into 4 different criteria: smart metering and monitoring, operation and maintenance control, performance assessment for final rating, and innovation. So in this, I must say that this section promotes smart metering and monitoring of energy for water consumption. What is smart metering and monitoring? First thing is, the project should basically comply with the minimum requirements, metering requirements for energy and water, which is the energy from the grid utility grid should have a meter, or if it has an on-site renewable system, then that should be metered. If it takes energy or consumption of energy from diesel gensets, if there are multiple buildings in the project, then meters should be provided at each building level. And in water, the basic metering requirements is the project has to meter the amount of water consumption or provide a meter at the municipal supply inlet, the borewell, if the water is using STP and the water is being reused, if it's using the captured rainwater, and again, if there are multiple buildings in the project. So all these comes under basic metering, which means we are understanding the inlet of all the sources of energy and all the sources of water. Smart metering is if you add furthermore meters to measure the advanced energies, which is advanced energies in the sense if there is a meter which also measures HVAC, central plant energy consumption, or separately for lighting, indoor and outdoor lighting, or separately for UPS, or a separate meter for lighting which is provided in basement parking. All these are a step ahead of rather than basic metering and monitoring. And in terms of water, if it is provided the irrigation water, a meter near the irrigation water inlet, meter near the cooling water, meter near STP. If there are multiple buildings, each building, if there are multiple apartments and commercial tenants, each apartment and commercial tenant. So this makes sure that the project is measuring and monitoring what is happening in the project. And next comes operation and maintenance protocols. Why is this necessary? The project through this GRIHA ensures the implementation of an operation and maintenance protocol. As I already mentioned before, that if a system, no matter how efficient it is, if it is not properly maintained, then the efficiency is not met and it in fact becomes a burden onto the project. So maintaining these equipments or the systems which are installed in the project also plays a major role. If it's a bigger entity, the project has to come up with a team of people who will take care of operation and maintenance. They have to come up with a manual book wherein all the manuals or all operation protocols of all the systems included or installed in the project are put together. This is how operation and maintenance protocol works. And performance assessment for final rating. So the intent of this criteria is to validate the performance of energy, water, and comfort conditions in the building as predicted during the design and development stage. All the systems. So now we have understood that all the systems, all the equipments are there in place. Now we have to check whether the thermal conditions or visual comfort conditions or acoustical comfort conditions or the energy systems or water systems are properly maintained, working to its full efficiency or not. And then comes the innovation. So the project has a scope of gaining points in this section, in this criteria, because this helps in promoting adoption. This criteria ensures in promoting adoption and implementation of innovative strategies, improving the sustainability of that project. What can be considered under innovation? If a GRIHA certified professional, who is GRIHA certified professional, a person who gives GRIHA CP exam and gets certified by GRIHA, if a project team has a GRIHA certified professional involved in the project, or if the project is using or implementing a technology for the first time in the country, or better e-waste recycling measures, or STP, much more efficient STP technologies, like these, there is no end to that list. If the project comes up with innovation in their project, and it is up to the discretion of GRIHA to accept it for a point or not. That is how GRIHA rating version 2015 has been encompassed with 9 different sections and 31 different criteria. There I end the description or the overview of GRIHA version 2015. Now we'll move on to few case studies. Yes, as I was mentioning, Akshaya Urja Bhavan. If you remember, this is the floor plan I was showing you before for urban heat island effect. How urban heat island effect is reduced. So let's look at this case study. This is Akshaya Urja Bhavan, which is Hareda, Panchkula, which is in Haryana. The site area is of 3,900 meters square, where the condition area accounts for 76% of the total built up area. And this project marks for 61% of energy consumption reduction compared to GRIHA benchmark with an EPI of 17 kilowatt hour meter square per year. It's completed in the year 2012 and has been awarded GRIHA provisional rating of 5-star. So the project has adopted strategies such as site planning, reducing energy and water consumption. Renewable energy technologies have also been installed on the site. As I was mentioning earlier, the building is placed on north-south axis in order to receive sun from the southern side. Most windows are placed on north-south facade of the building to keep the building naturally daylit. East and west windows are oriented towards south to have easier sun control through the shading devices. Toward the south, there is a widespread of landscape area. The height of the building considered is such that the shadow on the neighboring building is minimized. In terms of reducing water consumption, efficient fixtures were used, accounting for 70% of annual water consumption reduction with respect to GRIHA benchmark. 6.25 liters of rainwater storage tank has been designed in the basement to collect water from the roof and courtyard. Percolation pits along the driveways for collecting rainwater. Overflow, which will be directed to municipal sewer, is directed to municipal sewer. The collected rainwater is then treated by pressure sand filter and activated carbon filter and further used for portable use, HVAC plants, and also horticulture. Solid waste is directed towards municipal sewer lines. Central courtyard, as I was mentioning, central courtyard and single loaded corridor help provide visual comfort by natural light, and solar chimneys were built towards the south facade. If you look at this, in the south, where living areas are marked, solar facade has been, solar chimneys were built towards southern facade to aid the ventilation. Roofing tiles with high albedos to reflect the maximum solar radiation. And in terms of renewable energies, 42.5 kilowatt of solar power, solar photovoltaic panels, and 5 kilowatt of building integrated photovoltaic panels above the courtyard were installed in the project. So the door and window frames, AAC blocks have been used in the project are of low energy building materials. So if we look at all the criterias, wherein we talk about the orientations, we talk about the low impact design strategies, we also talk about the low impact materials or low embodied materials. So all these were included, or all these were adopted in this project. Let's look at another project, which is Govardhan Eco Village. I hope most of the students have already heard it. I suggest you go for a site visit as well. It's a pretty interesting project. It's located at Galterwada, Thane, Maharashtra. Site area of the village 70 acres and 57% of energy consumption reduction compared to benchmark of EPI of GRIHA. So throughout the site, it is non-conditioned, completely non-air conditioned spaces. It's completed in the year 2012 and has been awarded GRIHA provisional rating of 5 stars. So the layout was envisioned based on the hydrogeological survey's inputs so that the development does not impact the recharge and discharge zones of water negativity, which means a proper care was taken during site planning to understand the positives and negatives of the site and plan accordingly and take the advantage of the positives. The massing has been done in a way that minimal trees are cut, continuing the agriculture. In the project, minimal trees were cut and the design has been developed in such a way to reduce the tree cutting. Building was built on a hard ground, saving on the foundation cost, where we are looking at reduction of the cost and reduction of the material which are being used. And using stabilized solid soil cement blocks on walls, leaving them unplastered, which again accounts for a local material and a lower embodied energy material. And replacing the sand with quarry dust, which means using the BIS recommended material. Precast arch panels for roofs and double tile for roofing, wherein these precast arch panels will take all the load of the roof. And if you look at, there is no RCC slab in this project. If you look at the pictures, it is a double tile roof. And the spaces were provided with optimum window openings, light colored floors for light diffusion, soft landscape outside, avoiding reflected glare, and shaded walls and openings. So this project is also equipped with solar electric panels of 30 kilowatt capacity, solar water heaters of 500 liters capacity, biogas plant processing the food waste and animal waste and producing 30 cubic meters of gas, soil biotechnology, a green sewage management technology, recovering up to 95% of the sewage water, which is used for landscaping, can also be seen in the project. So this is about Govardhan Eco Village. I end my presentation with this case study of GRIHA rated building. And I would like to tell you how GRIHA is helpful for professionals and students. An individual can become a GRIHA evaluator or a GRIHA certified professional. As I was mentioning, in innovation, if the project team has a GRIHA certified professional, will gain 1 point in innovation section. And for students, there is something called a student membership ACE, which is Agents of Change for Environment. So for an organization, if they are manufacturers or manufacturers of a product, there is something called GRIHA product catalog, which is developed to help people to understand what are green materials in the market, because there are many materials which are coming in the market claiming that they are green. There is also associate membership for the organizations who are committed to sustainable built environment, like green consultants, who can join hands with GRIHA and become associate members. There is a program called Catalyst, which is creating awareness through academics, leading to youth sustainable transformation, which is bringing together institutional heads towards a common goal of educating and sensitizing youths about sustainable habitats. So I suggest all the students or professionals to look at the options, or how you can get associated with GRIHA or to the sustainable built environment. Thank you. And I'm Sita Malakshmi, your presenter for this session. You can also download, there is a GRIHA app available on iOS and also Android. You can download that. It will be helpful for students also. And you can connect with us on Facebook, Twitter, LinkedIn, and also Instagram. Thank you for participating in this webinar. You've been such a great audience, and I could see that a lot of response has come in terms of polls as well, and most of you participating, and I hope you've understood the basic intent of GRIHA and its structure and how GRIHA looks at sustainable buildings, what all it considers. And I would like to inform you that a recording of this webinar will be uploaded soon on GRIHA website. If in case anybody has missed this webinar, they can look through the recording, which will be uploaded sooner. And to repeat, the answers to your queries posted, if are not addressed during this webinar, also will be uploaded in the GRIHA website with all the answers soon. You can check back and keep browsing through GRIHA website for more webinars and more kind of training programs which are coming further. Thank you. I end this session for today.